Assalamualaikum, students and friends. Today's episode is a sequel to the previous upload, Periodic Properties of Elements. This time, we focus on ionization energy of some representative elements. So, what is the trend for ionization energy within a period and within a group or family? We'll find out. Just stick around, watch and learn. The question is, in each of the following sets, which one has the highest ionization energy? Number 1, helium, neon, argon, radon, or krypton. Set number 2, magnesium, arsenic, aluminum, or fluorine. And set 3, potassium atom, potassium positive 1 ion, calcium atom, and calcium positive 2 ion. When we use the term ionization energy, we usually are referring to the first ionization energy. So it is the minimum amount of energy required to dislodge the least firmly attached electron from an atom in the gaseous state. For example, sodium atom has its first ionization energy equal to 119 kilocalories per mole, which when converted to joules, that's equivalent to 4.99 times 10 to the fifth power joules per mole, or in electron volts, that's also equivalent to 3.12 times 10 to the 24th power electron volts. So, this means that 119 kilocalories of energy must be supplied to remove the first or the least tightly held outermost electron from each atom in 1 mole of sodium atom. What is the trend for the first ionization energy? So, the first ionization energy for the atoms going across a period that's from left to right generally increases. Even if the elements belong to the same main energy level or energy shell, the nuclear charge or electrostatic force of attraction of the protons to the outermost electron or electrons is generally increasing. Although the general trend within a period is increasing from left to right, group 6A elements have lower ionization energy compared to elements belonging to group 5A because in group 6A, the first electron is removed more easily due to the remaining half-filled set of p orbitals. All right? So, as an example, we have uh, the element 7, nitrogen with 7 as its atomic number. All right? It belongs to group 5A, while oxygen with atomic number 8 belongs to group 6A. All right? Nitrogen's first ionization energy is in fact 14.6 electron volts, while that of oxygen atom, its first ionization energy is 13.6 electron volts. All right? So, this is one of the deviations from our general trend, all right, for atoms or elements belonging to the same period, all right. So one exception to that rule, that as you get from left to right, the ionization energy is supposed to be uh, increasing, but the case of nitrogen and oxygen somewhat deviate from such trend. Another example of elements belonging to the same period, all right, whose first ionization energy doesn't seem to follow the trend, all right. We said that within a period, um the first ionization energy increases from left to right. But let's look at the case of carbon with atomic number 6 belonging to group 4A and with the first ionization energy equal to 11.3 electron volts. And then, adjacent to carbon, of course, a boron, atomic number 5, belonging to group 3A. Its first ionization energy is 8.3. All right? So, in this case, there is no what we call deviation. All right? Because carbon, the carbon element is to the right of the boron element. So it is expected that its first ionization energy will be higher, all right, than that of boron. But if we check the second ionization energy for each element, we have carbon has 24.4 electron volts as its second ionization energy, while boron has 25.2 electron volts. So obviously, that of boron is greater, right? And this is what we mean by deviation from the periodic trend. All right. Um, we say that as far as the second ionization energy is concerned, one possible explanation to this is that it is easier to remove an unpaired electron with a remaining s2 configuration, which we are going to illustrate in just a short while. Checking the electron configurations, um, for the element nitrogen, all right, which is 1s2, 2s2, 2p x1, 2p y1, and 2p z1, all right? That means its valence or outermost electrons are distributed, all right, um, in the manner that the 2s orbital is completely filled with 2 electrons, all right, while the three 2p orbitals, 2px, 2py, and 2pz, has 1 electron each. So we say that the p orbitals are half filled with electrons. Now, for oxygen, all right, or oxygen atom, its electronic configuration or electron configuration is as shown: 1s2, 2s2, 2px2, 2py1, and 2pz1. All right. So the 2s orbital oxygen is fully filled with 2 electrons, of course, and the three 2p orbitals, all right, uh, there is one p orbital that is completely filled, all right, with 2 electrons, and then the other p orbitals are half filled with 1 electron each, all right. So based on this configurations, okay, what can we deduce? We say that it is easier to remove 1 electron from oxygen than to remove, all right, an electron from nitrogen because of the remaining half-filled set of p orbitals in oxygen. All right. Now, for element carbon with atomic number 6, its electronic configuration again is as shown: 1s2, 2s2, 2px1, py1, and pz with no electron. All right. So um, carbon also has its s orbital completely filled, and the three p orbitals, only 2 p orbitals are half filled with 1 electron each, and 1 p orbital is empty. All right. So that's for carbon. And for boron, the configuration is 1s2, 2s2, 2px1, all right, with py and pz, uh, neither of these orbitals py and pz have an electron. All right. So only one p orbital is half filled with an electron. All right. So again, what do these configurations of carbon and boron tell us about their ionization energies? Right? We say that it is easier to remove the first electron, right, from boron than from carbon. All right? The reason is that uh, in carbon there uh, there are two p orbitals that are half filled. All right. Um, in the case of boron, with two p orbitals empty, so removing that uh, electron from the px orbital is uh, much easier to do. All right, compared to removing that one electron from 2py orbital. All right, because of the presence of 1p orbital that is half filled with an electron. Now, it is much harder to remove the second electron from boron than from carbon because this second valence electron of boron is tightly attached. All right, and it is, shall we say, kept stable at the 2s orbital. So it's not that easy to remove uh, even one electron from the 2s orbital for boron, right? That's the reason why the second ionization energy of boron is higher compared to that of carbon. Now, for elements belonging to the same group or family, we have this trend. The first ionization energy decreases from one atom to the next as one goes down a group or a family. All right? The valence electrons are in a higher energy level or at a farther distance from the nucleus, which means that the nuclear attraction, okay, meaning the attraction of the protons, okay, found in the nucleus to the what we call outermost electrons. Thus, it is easier to remove those electrons. All right. Moving on now to our answers and explanations. Right. Question number one: which among the noble gases has the highest first ionization energy. All right. So the noble gases are helium, neon, argon, radon, and krypton. Uh, Xenon is not included here. All right. So in the modern periodic table of elements, the noble gases are arranged in a vertical column. All right. Just like what is shown in this diagram. Helium is at the topmost position, and radon is at the bottom. And since the trend, all right, uh, states that the first ionization energy decreases from one atom to the next as one goes down a family or a group, all right? So that means among these five noble gases, okay, the highest, or the one with the highest first ionization energy, of course, is no other than helium. So for question number 2, which among the elements magnesium, arsenic, aluminum, and fluorine has the highest first ionization energy? All right, so as you can see in this modern periodic table of elements, the four mentioned elements are now being highlighted. You have here magnesium, all right, and aluminum. This is arsenic here, and of course, that's fluorine. All right, so we have here the relative location of the elements in the periodic table. All right, and since our rule for the first ionization energy is that it decreases from top to bottom and increases from left to right. All right, so it is pretty obvious that the element with the highest first ionization energy is no other than fluorine. Finally, we are now on our last question. Which among the species potassium positive 1 ion, neutral calcium atom, and calcium positive 2 ion has the highest first ionization energy? All right, so we know that potassium and calcium are both in period number 4. All right, so according to the trend, we are expecting that calcium will have a greater first ionization energy compared to potassium. And upon verification, indeed, calcium has the greater first ionization energy, equal to 11.9 electron volts, as compared to that of potassium atom, which only has 4.34 electron volts. All right. So this comparison of the first ionization energy between calcium and potassium agree with our trend for the same period. All right. The first ionization energy increases from left to right. All right. Now, we can also use the electron configuration of each of these atoms. For instance, potassium, all right, whose atomic number is 19, can be represented by this shortcut electron configuration using what we call the bracket argon notation. As you may all know, argon has a total number of 18 electrons. All right? So its atomic number is 18, of course. And this uh, noble gas, okay, argon, represents the inner electrons of potassium. All right? The 18 inner electrons found in the lower energy levels, 1, 2, and 3. All right? The outermost energy level is represented here by 4s. All right? 4 also being the number of period. All right? And as given here, there is only one electron occupying the outermost energy level. So we say that the valence electron of potassium is 1. Now, for calcium, whose atomic number is 20, its electron configuration using the same notation, bracket argon, is 4s2. All right, 4s2 being the outermost energy level, and there are 2 electrons occupying the s orbital. All right, so looking at these 2 configurations, it's obvious why calcium should have a greater first ionization energy than potassium does. It's because it's easier to remove the single electron or valence electron of potassium. All right, because this electron uh, in the s orbital is not that stable. All right, whereas in the case of calcium, the 2 electrons in its outermost orbital, 4s orbital, the 2 electrons are said to be very stable. All right, and it takes a much greater energy to dislodge, all right, even one single electron from 4s2. All right, so that's the reason why calcium has a uh, greater first ionization energy compared to potassium. Now, how about their corresponding positive ion? All right. In the case of potassium, when potassium loses an electron, it becomes, or it will have a configuration identical to that of argon, because as shown here, all right, the outermost energy level 4s, all right, is already empty. All right, once potassium uh, loses an electron, all right, the reason why it becomes a positive ion, all right, because it is deficient of one electron. But notice that even if the configuration of potassium is the same as that of the noble gas argon, they are not exactly the same. All right, it is because when potassium loses an electron, the number of protons in the nucleus of potassium or potassium ion still remains 19. All right, there are 19 protons. All right, but there are only 18 electrons. So we say that it is one electron deficient. All right? That's how we describe the atomic structure of an ion, such as a potassium positive 1 ion. How about the calcium positive 2 ion? Its configuration is somewhat similar to that of potassium positive 1 ion, except for the fact that upon losing two electrons, all right, uh, the number of protons in the nucleus of calcium ion still remains 20, all right, as compared to that of potassium, which only has 19 protons, all right. So, as far as their ionization or first ionization energy is concerned, all right, you already have established that calcium atom has a greater first ionization energy than potassium ion. And we have explained that earlier. But between a potassium atom or a neutral potassium atom and a positively charged potassium ion, all right, we say that the first ionization energy of the potassium ion is or must be greater, all right, must be greater than that of the neutral potassium ion, all right. Similarly, in the case of calcium positive 2 ion, uh, its first ionization energy must also be greater than that of the neutral calcium atom. All right. The reason for this is that uh, an ion or a positive ion, that is, will have a greater what we call nuclear charge. Just like what I mentioned earlier, uh, once potassium loses an electron, the number of protons in the nucleus of potassium still remain intact. All right. That means the attractive force from the nucleus will be much greater compared to the neutral potassium atom. All right. Because here now, in the case of potassium positive ion, the 19 protons will be exerting an attractive force on the electrons of potassium ion found in the inner shells as compared to that of ordinary neutral potassium atom having only 19 protons. All right, so that's also true in the case of calcium positive 2 ion. All right, its nuclear charge is much greater compared to the neutral calcium atom. All right, for the same explanation. All right, it is because of the greater nuclear charge that is established once an atom loses one or two electrons. All right, so in answering our question, which among the four species has the highest first ionization energy, it looks like that uh, calcium positive 2 should have the highest first ionization energy. The fact that uh, its nuclear charge, all right, after losing two electrons, all right, its nuclear charge is the most or the strongest, all right, as far as the electrostatic force is concerned. All right, so in a nutshell, we say that uh, calcium positive 2 has the highest first ionization energy, and that is our answer to question number 3. And that ends our discussion for this tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.